Hello, and welcome to today's Tech Talk, a new series that is part of our Velodyne Lidar live webinar lineup. My name is Jane Maynard, and I am the Senior Manager of Communications at Velodyne. Today's Tech Talk is part one of a two-part series looking at the questions, why intelligent infrastructure, and why now? Today, our focus will be traffic operations. Before we dive in, a few housekeeping items. At the end of the presentation, we will open up a Q&A. If you have questions at any time during the webinar, please add them using the Q&A button at the bottom of your Zoom screen. We will address as many as we can at the end of the episode. In addition, we will be emailing you a recording of today's webinar, so if you would like to rewatch, keep an eye on your inbox. With that, let's get on with the show. Today, we will be joined by Asad Lesani, co-founder and CEO of Bluecity, our AI partner for Velodyne's intelligent infrastructure solution. Before Asad gets going on today's Tech Talk, I wanted to provide some quick background. With over 450 customers across the globe, Velodyne Lidar's revolutionary LiDAR sensor and software solutions are uniquely suited to deliver the flexibility, quality, and performance needed to meet the needs of over 25 different industries, including some like industrial, robotics, automotive, and intelligent infrastructure, which is today's topic of conversation. Our LiDAR-based vision solutions are enabling our customers' applications to see the world in 3D. For example, it can help a drone to navigate a hard-to-reach area like a mine, or an autonomous shuttle transporting passengers in a dense urban environment. Or, as we'll discuss today, a city government tracking and analyzing traffic patterns to make a dangerous intersection safer. Here, you can see a variety of Velodyne's LiDAR sensor options, from rotational sensors that provide a full 360-degree view of the environment up to 300 meters. You may have seen some of these sensors atop or embedded into an autonomous vehicle driving around town. We also have solid-state directional sensors developed for a wide range of industries, like robotics, automotive, and industrial. From long range to ultra near field vision, our sensors paired with our software solutions can solve our customers' pain points and accelerate time to market for their autonomous technologies. One of our offerings is Intelligent Infrastructure Solution, also known as IIS, which is how I will refer to it from here on out. This combines Velodyne's LiDAR with Bluecity's AI. We were so happy to join forces with Bluecity for this full stack hardware plus software solution designed to help governments solve some of their most challenging and pervasive infrastructure problems. IIS has already won multiple Smart City and Tech Awards, including the South by Southwest 2022 Innovation Award, which was incredibly exciting. And I had the opportunity to travel to Austin with our guest today, Asad, to accept that award at South by Southwest. It was great, and we saw an intersection in action, so it was a fantastic experience. So what does IIS do? IIS generates real-time data analytics and predictions to improve traffic and cloud flow efficiency, which will help protect vulnerable users like pedestrians and more. It also runs 24/7, 365 days a year in all lighting conditions and weather. The magic of IIS is that it enables civic and transit leaders to take a proactive approach to keeping their communities safe. With real-time data, cities can identify problems and then employ database planning. For example, with IIS, cities and departments of transportation can quantify near-miss data in real time to proactively improve roads and intersections and ultimately save lives. We are so excited to hear from our partner Bluecity today. I am now going to turn the time over to Asad Lesani. He's co-founder and CEO of Bluecity. He's going to take us further into the technology that powers IIS, especially as it pertains to traffic operations. Thank you so much for joining us today, Asad.
Thank you very much. So let me share my screen. Perfect. Thanks, Jen, for the introduction. I'm super happy to be here and talking about IIS solution and how we are helping cities with different applications for better traffic management. So I'd like to start giving you a little bit background about like the different segments that we see in a traffic management system in general in cities. There are groups that they are working mainly on traffic operation, how we can move people faster, better, reduce congestion. And then there are people that they are more focused on traffic planning, more like long-term planning of cities, infrastructure planning. And then we have groups that they are more focused on improving safety as a part of Vision Zero activities, and in general, how we can make your road safer for vulnerable road users. And also groups that they are more focused on making sure that our cities are ready for future mobility. For example, connected vehicles, autonomous vehicles, robots, etc. So the backbone of all these activities is traffic data. So that's why those people typically use different type of technologies to capture the data they need. So when it comes to traffic operation, they need a system that works 24/7. That's why we see radars and inductive loops being used for capturing data for those applications. But radar and loop necessarily doesn't provide multimodal data, so they're not cost effective, but they provide reliability that we need for 24/7 applications. On the other side, we see camera-based technologies, which provide multimodal access with pedestrian and cyclist detection, classification of road users, but they suffer from lack of reliability when it comes to the 24/7 applications. And then always there's a privacy concerns. And now that as a city, if you have all this information, you need to find third parties, or if you have a big group that they can start converting those traffic data into insights that they can use it in their daily activities. So typically they hire third parties or consultant to provide those analytics. And then if you want to really look at the future of the mobility, so you need to have systems that can share data with connected vehicles and autonomous vehicles, making sure that we make cities safer from different aspects. So that's why we typically use, we need to have technologies that can work reliably in a multimodal traffic data, so then we can share insights and information with connected vehicles, let's say for V2X safety applications. That being said, so what we are working on in our company on using LiDAR technology to address the challenges of existing technologies, what we can provide an automated system for collecting data, converting into insights for different applications. And that's why we are using LiDAR technology, because LiDAR generates real-time traffic data 24/7. It's not affected by the weather and lighting conditions. We can capture multimodal traffic data, detecting different type of road users, pedestrians, cyclists, etc. So it's a cost-effective technology. We typically install one single sensor at the corner of intersection. It's privacy protected, so there's no way that we can identify face of people, collect any biometric data, and it's powered with our advanced analytics that I'm going to talk about those measures and parameters that we are measuring for municipalities to enhance their traffic operation and safety. So as I mentioned, our goal is to build a system that different stakeholders in the city can leverage a single sensing technology for traffic actuation, which we need access to data 24/7, for traffic planning, which means that we need to have access to historical data, for Vision Zero activities, which means that we need to convert this information into ready-to-use insight on safety of road users, near miss detection, red light runners, etc. And also making sure that we can use this technology for as a part of the future of the mobility for cities, for example, V2X application, etc. The focus of this webinar is mainly on the traffic actuation and traffic planning, how we can collect data, feed data to the controller, and also how we can use this data to measure some important factors that cities are using for planning and traffic operation improvements. And then in our next episode, we're going to talk about use our technology for Vision Zero and the V2X applications. But I'd like to start just giving you a little bit background on how LiDAR works. LiDAR stands for light detection and ranging. It generates real-time 3D representation of whatever is in front of sensor. In this case, it's an intersection. And all those white points, or let's say circles that you see, it's basically LiDAR measurement of distance. It's a LiDAR measurement of distance. LiDAR repeats its hundreds of thousands of times every second, and we can build a 3D representation of the environment in front of LiDAR. And then we build an AI perception software that converts raw LiDAR data into object detection. And as you see, we can detect cars, and we're gonna have pedestrian detection, cyclist detection as a part of our system. And then at the same time, you see that we have some virtual loops, or those polygons that you see. It's basically those are virtual loops that we are using for traffic actuation. You're going to see more details in a couple of slides. And then we connect to the traffic controller, so that's why you see different colors for those virtual loops. Now, let's say for main application of the solution, we're targeting using this technology as a replacement, as a cost-effective way to collect data as a replacement of inductive loops and radar-based solutions. So what you see here on the right side is a bird's eye view of LiDAR in one of our intersections in Canada, which is basically, you see that there is one single sensor at the corner of intersection is scanning the intersection, and we draw those virtual loops that you have different colors, and those virtual loops will be used actually for feeding data to the controller. So we're using NTCIP to communicate with controller, and we already tested with 5-6 different vendors in North America that we are compatible with those controllers to be able to have a bidirectional communication, feeding data when we detect an object as a replacement of inductive loop. But even for more advanced analytics that we're providing, such as signal performance measures, we need to read signal timing plan. So the way that our system works is every 100 milliseconds, we are reading current signal timing plan from controller, and we're bringing into our analytics. And that's why in that demo, you see we have different colors assigned to those virtual loops because we know which phase is green in real time, which one is red. And on the left side, you see a digital representation of the intersection. So we opened up our API, which means that as a partner or customer, you have the opportunity to use our API to extract real-time traffic data that we're generating at the intersection. Really a low level, we have an API, we call it real-time API, which every 100 milliseconds, we're broadcasting information about all the objects that we're detecting, including class of road users, their location, their timestamp, their speed, direction. And then we also provide some Python and sample codes that converts this information into geolocation, so we can easily build a digital twin of whatever is in front of the sensor in real time. And then we are actually using this API and sharing this information with our V2X partner that I'm going to talk about that in our next episode about using and sharing this data with connected vehicles, more focused on safety improvement applications. So this is an intersection that we have one LiDAR, but in some of our intersections, we have, because of the size of intersection and number of heavy vehicles that we might have, we have the opportunity to fuse data between of two LiDARs. We still use an edge computer, and then we connect both LiDARs to a single edge computer. And then we're fusing data coming from two different LiDARs. And the reason that we're doing this is because we want to minimize occlusion problem when it comes to the, let's say, occupancy detection or stop bar detection application. So we want to make sure that we can provide reliable data for those applications. That's why we are putting one LiDAR in one corner and then second LiDAR in the opposing corner of the intersection. So and then we fuse detection of these two LiDARs to enhance the performance of system, especially for those large size intersections. So now that we have this technology using for traffic actuation, at the same time, we are using APIs to transfer this information to our cloud platform, where we run our different layers of analytics on top of traffic data, which basically starts with city planning data. So city planners are using traffic data to calibrate and run simulation that evaluates the use of urban infrastructure. So for example, how traffic flow changes over time. So during peak hour and off peak, during daily traffic patterns, and also analyzing seasonal traffic pattern, and then using traffic flow data to build the statistical models that describes the overall traffic pattern in the city, which is really critical for a better decision making, infrastructure expansion and modification. So with our system, you can get access to 24/7 data, which enables cities to get real-time insights about traffic pattern, recalibrate their simulation software, will generate more accurate, let's say, short-term traffic prediction using simulation software that city planners are using. So on top, you see the count data. As I mentioned, we classify road users. We know how many passenger vehicle, truck, buses, and on the right side, you see how many pedestrians, cyclists. We count object returning movement. So for example, you know how many cars going from north to east, north to south, north to west, and we do this for all 4 approaches. Now you have access to this information as a CSV file. You can download it, or you can use our API to extract this information. And the main reason is that some of the cities, they already have their own data management system. So they want to extract this information 24/7 with our API. So then they have the access to this information. And below you see some analysis on speed data. So on the left side, you see already average speed of each approach, mainly on the true movement vehicles. And the right side, you see within that time range that you select, you're going to see what's the minimum speed, maximum speed, median, etc. So now that we have this information, we also analyzing information about the location of the object overlaid with the signal timing plan to offer, basically we're generating different type of signal performance measures. So our platform automates the process of collecting data, analyzing and calculating performance measures, and providing easy to use visual representation of those measures 24/7, while you can use this system for traffic actuation. So it provides a tool to support objective and performance-based approaches to traffic signal optimization and maintenance management and design to improve safety and mobility. So how we're doing this, I'm going to talk about different type of safety signal performance measures that we have as a part of our solution. And I'm going to use one of our current installation at City of Austin, Texas, that we basically have a sensor on the on the north east corner of the intersection. And basically this demo shows how system sees the intersection. So we have defaultly we have connection to the traffic controller. So in real time, we know signal timing plan or SPAT information. And then we define virtual loops as always. So we have virtual loops as stop bar detection system, as well as some advanced loops that we use it for some of our SPMs that they need to have access to traffic pattern, not just at the intersection, but also 60, 70 meters back of stop line. And those are areas that we're covering right now, something around 70, 80 meters coverage area with a single sensor as a radius around LiDAR. So starting with signal performance measures. So the first parameter that it's really important for analyzing traffic operational issues is occupancy ratio. Occupancy ratio is basically defined as percentage of the time that the stop bar detection is actuated, which means that there is a object on top of it. So, and this is happening during red light, green, and first 5 seconds. And there are use cases around having access to this information, so we can quantify the use of phases, what percentage of time allocated green time is being actually used to serve a demand. So to evaluate any citizen complaints regarding stopping at the intersection and not being, like, let's say, served by traffic light. And also, so what we can definitely use this as an example to identify areas with high occupancy ratio during first 5 seconds of red light, and then and also evaluating this with the areas that we have high occupancy ratio during green time. So again, like, these are measures that typically city planners are using to identify any operational issues, but we are automating this process for customers. Instead of just sending someone to manually collect this data or evaluate this, everything is available 24/7. So beside occupancy ratio, you're going to hear our occupancy ratio in a couple of slides because occupancy ratio is the core to measure a couple of other important parameters that cities are using, for example, split failures. Next parameter that we are calculating is basically indicates the percentage of green time allocated to each phase at the intersection. So you can use green allocation to confirm that the design timing plan or desired, let's say, timing plan at the intersection and splits are deployed are deployed and the controller is working well. So this is something that you can expect from the current timing plan. And also on our next parameter, we measure phase intervals. We provide visualization on phase intervals, which basically shows the duration of red, green, and yellow phases for each cycle over 24 hours period. And then, so with access to phase interval, you can check if the controller keeps the cycle lengths at defined let's say you define it at cycle lengths at 120 or 160 seconds. Using our phase interval, you can actually see that if that current cycle length is actually happening at the controller instead of just going to the intersection and see what's going on. So you can find phases that are always maxing out. So this is a parameter that typically cities are implementing on their controller. So you can actually proactively measure those parameters and see if that is happening or not. And also checking how those phases are terminating at the controller. So phase interval with occupancy ratio gives you insights about performance of the intersection. As an example, a high green interval on a minor approach with a low green occupancy ratio, it shows that there is an unused green time at the intersection that can potentially be allocated to a major approach. So again, like these measures at the same time gives you those insights that you need to identify any operational issues. But as I mentioned, occupancy ratio and phase intervals are two key measures that we converted into a couple of other parameters that are important, and one of them called split failure. So basically, split failure happens when you have a, let's say, 20-second green time in one of the approaches, and then after 20 seconds, you still have some demand in that approach that it's not served, which means that there is a split failure happening at the intersection. So the way that it calculated is each single signal cycle. So we are evaluating by comparing the green occupancy ratio for the first 5 seconds and an occupancy ratio during the green time, which means that if you have a really high occupancy ratio during green, and then you have for the first 5 seconds of red just after that green, you have a still high occupancy ratio for red, it means that there is an unserved demand, and those are split failures that we see. So again, like we use split failures to evaluate intersection performance from a split allocation perspective, how to allocate green time to other phases in need, and also evaluate effectiveness of servicing intersection movement. So for example, in this chart, what you see here is a scatter plot of all cycles and with respect to their split failure or in general split. So for example, on the bottom left, you see bottom left part of this chart basically indicates potential excessive capacity for that movement. So on the top left, you're going to see an indication of random arrival patterns, which basically is you have a high occupancy ratio during first 5 seconds, but you don't have anyone using or like occupying a virtual loop during green time, which means that during green you don't have any demand, but just right at the first 5 seconds you have a lot of demand for that approach, which means that there is a random arrival pattern at the intersection. On the bottom right corner, you see another measure that as another part of measure that is basically indicating an excellent green allocation utilization, which means that green time serves the demand within allocated green time without leaving any residual demand just after red light. So and also on the top right, that's the area that you want to pay more attention, because that indicates split failure. That means that, as I mentioned, the allocated green time is not enough to serve the demand, and some residual demand will remain unserved. So now you have this information as a scatter plot, so you can easily compile multiple approaches. So for example, these two snapshots that you see here, on the right side is a major approach, and on the left side, which is phase number 4, is a minor approach. You see that while we have a lot of spare capacity in major approach, which means that you have green time that no one is using it, and the left side, you see a lot of split failures, especially during peak hour, that you see all those black dots, which means that you can potentially get some of the green time allocated to phase number 2, which is a major approach, and give it to phase number 4 to balance the traffic pattern and use of intersection with respect to the current timing. But now you have this scatter plot, so you want to find a way that you can see distribution of those split failures over time. So you want to see when those split failures are happening, and that's another parameter that we measure called the split trend, which it basically decodes the split failures into 24-hour charts to see trends over different time of day, and also in the way that probably you can interpret that is, like as I mentioned, is split failures, which indicates unused demand for that phase. Heavy traffic that shows a highly saturated phase can potentially lead to a split failure. Okay, which is basically indicates excellent green allocation of and use of green time, and also random arrival that shows basically you're having vehicles arriving during red, but no one was there during green time. And also spare capacity, which basically indicates that you are assigning a lot of green time to a specific approach, but no one is actually using that green time. So, and one of the other parameter that I want to quickly talk about is Purdue coordination diagram. Most of previous measures that you saw, we were talking around how we can measure operational issues at that specific intersection. But if you have a coordinated system, or if you have an arterial that you want to generate green wave in that arterial, Purdue coordination diagram is the chart that can be helpful for those use cases, which basically overlays arrival of each vehicle detected by our advanced detection, and then overlaying this information with each phase timing at each cycle. So in that case, you can see if cars are arriving during green or during red, if cars are arriving as a platoon, which is the goal of building green wave or coordinated systems. So, for example, some of the issues that you might see is like a large cluster of vehicle arriving during red, which means that the coordination doesn't work. Or if in best case scenario, you see that a large cluster of vehicles arriving during green, which is the ideal scenario. So you want to move them around the corridor, hitting different multiple green time. And then if you, let's say you have some just random dots that you see on those charts, especially if those are around red light, which means that they are all random arrivals, which shows that your platooning doesn't work. So it could be your controllers are not synced, or your offset is not correct. So again, this Purdue coordination diagram helps with identifying those issues at the intersection with respect to the coordination between multiple intersections. With respect to the hardware components that we have in our system, so definitely we have LiDAR, we have a POA splitter, and then we have an edge processing unit, which we can place this inside the traffic cabinet. It's a ruggedized system, so it's IP67. You have the option to also attach it to the pole, the same pole, mainly for areas that you don't have enough space in your traffic cabinet. You can easily place that edge computer on the same traffic pole. And then we are communicating with traffic controller over NTCP, so it's an IP-based communication. So we can connect our edge box to the switch inside the traffic cabinet. For data telemetry, we have different options. In most of our projects, we're using city fiber network. Everything is behind city firewall, so for the security purposes. And also, we have the option to use LTE and potentially 5G. So we have a couple of 5G projects that mainly for research projects that want to leverage low latency applications, 5G. And then between Edgebox and PoE splitter is going to be just one Cat6 cable that brings power and data to the LiDAR, which basically helps to make the installation way easier and cheaper. So I'd like to summarize the presentation. So today we talked about a data-driven approach on improving traffic operation. So we covered the challenges of existing technology, why we're using LiDAR in our solution, how LiDAR works in general to generate real-time traffic data. Also, we talked about use of LiDAR for traffic signal actuation as a replacement of inductive loop, and which is our traditional monitoring system for traffic actuation, with more flexibility and cost-effective way, as so we can use virtual loops for pedestrian detection. Let's say if you want to extend green time for pedestrian, or you want to extend red light for vehicles to make sure that pedestrian crosses intersection safely, you can use virtual loop concept for pedestrian and other type of road users. We also talked about how LiDAR can be used to extend traffic actuation from a car-centric actuation to all road users with the capability of defining virtual loops for pedestrians, as I mentioned. Also, our open API architecture builds a collaborative environment. We're working closely with 3-4 different university partners that they are really building innovative solution on top of our technology. We believe that this problem that we're targeting is not a problem that a single company can handle. So definitely we need to have a collaborative environment with our customers, which are typically cities, our partners, researchers, to make sure that we leverage data not only for current problems but also for the future of mobility. We talked about different type of signal performance measures. There's no single measure that can provide all the information. So it's very important to get all those measures in one platform for a better comparison and conclusion. And also something that I'd like to talk about is an inefficient traffic operation system can affect safety as well. So when we were looking at those like red light runners in our system, so we've seen cases when we're evaluating safety. So, and then we identify red light runners that cars basically stopped back of stop line and they just drove red light when they saw no one at the other corner of intersection or other approach that they have green time. So, which means that potentially if you improve your traffic operation and really try to serve it based on the demand by accessing the real-time data, you can potentially help with to improve help and improve safety of road users. So in our next episode, we're going to talk about the use of our technology for safety improvement and our surrogate safety platform that provides 24/7 information about safety issues, including near miss detection, red light runners, or speeding. And also we're also going to talk about how we are using our technology for future mobility and sharing data with connected vehicles. Thank you very much for your time. I would be happy to answer any questions.
All right, we have questions. So here we go. Thank you so much for that. Asad, that was a great deep dive into the tech behind this. And I am going to resist the urge to talk V2X and safety because we'll do that next time. But it all just like starts building, and I'm excited for the next webinar with you. So as we wait, we have a couple questions coming in. I wanted to ask a quick question. So we had the chance to travel to Austin for South by Southwest, and while we were there, we visited the intersection that you gave data from in this presentation, the Springdale and 7th in the city of Austin. And when we got there, it was a little sobering because we saw a little memorial set up. So we were wondering why did they choose that intersection? And we're seeing all this great data they're getting from this intersection. Why was that one identified for their pilot program? And how is that data going to transform that intersection that we saw?
Yeah, that intersection is one of the dangerous intersection in Austin with respect to the crash that happened and fatality. I guess over the past 3 or 4 years, they had, I think, 3 fatalities in that intersection and 4 major accidents. And I mean, The reason that they are trying to find other technologies to address safety issues is that if you really want to solve a safety issue and just wait for a accident to happen to identify issue, this is not going to be efficient. And I mean, well, and the other issue is that even if you know already some of those intersections are dangerous, and then if you want to expand it to other intersection or find similar intersection that potentially you might have accident there, so you have to wait again for another accident. And then even if you solve it, so you have to wait another couple of years to see if it was effective or not. So in our technology, we're taking another approach, which is a proactive approach on safety improvement, which means that we are trying to measure some of the factors that we saw that there is a high correlation between those measures with the traffic accident. So, for example, number of near misses, so number of red light runners, number of overspeeding, and then overlaying this information that you're going to see a lot of details in our next episode about how we're doing actually those extracting those safety measures.
Great. Okay. One question is just about weather conditions. Is the system able to function in harsh weather? And I know the first time you and I connected on LinkedIn was a long time ago, and you had posted the map that you just showed us from Austin of Montreal in the snow, and that's how we got to know each other. So tell us about weather and how the system functions in weather.
Yeah, so I used to live in Montreal. I'm from Canada. So I think Quebec in Canada is the best place to test different outdoor technologies. So we have really harsh environment with respect to the weather condition. We have a lot of snow, freezing rain, minus 35, 40 degrees Celsius during winter, and then hot, humid summer. So that being said, when I founded the company, so we started testing this technology in Montreal. We collected a lot of data and there's snow, rain, etc. So when it comes to the snowy environment, yes, definitely data gets a little bit noisy, but we collected data a lot. So I mean, we probably collected and annotated data more than 2 million objects, and then we trained our deep learning models in different scenarios to address those challenges. So that being said, so LiDAR, I mean, we definitely believe that LiDAR is a great solution for those like harsh weather environments, which is really critical for traffic actuation use cases. And we also have deployment that I think we deployed, first deployment that is still running. It was in 2020 and early 2020. And it's still running. We haven't even cleaned LiDAR there, so which is great for maintenance perspective. So yeah,
that's amazing. That's fantastic. Okay, can you make a virtual loop for crosswalks or bike paths? If so, can this be shared with a traffic light controller?
Yes, actually, in one of our pilot projects, we're doing exactly that, like using this for that application. It's basically they have the problem that they have is like it takes time for people to cross the intersection, and they want to find a better way to detect those, and then not just using green time for pedestrian if no one is actually using it. So they want to make the traffic light adapted based on the demand for pedestrian. So the way that it works is, yes, we draw virtual loops for pedestrian, and then if there's a pedestrian on top of it, that loop will be activated so controller can see there's a pedestrian on top of it. The interesting point is that if there's a car on top of that loop, it won't be triggered. So it's basically loop is defined per type of road users, which minimizes false positives.
Great. Okay, as it relates to data analytics, some agencies do not have the resources to monitor the data from the sensors. Are you capable of providing those services in addition to the hardware and software solutions?
Well, yeah, I mean, what we are trying actually do like with our platform, data analytics platform, is exactly the same thing. So we want to minimize all the force that cities need to put or hiring third parties to convert traffic data into analytics. Just I'm going to give you an example. This is more like for safety, but it applies for SPMs as well. So right now, the way that cities are using segregated safety analysis is they are hiring a third party to put a camera, they record video, and then they send this video streams to another company, let's say, that they are doing analytics for near miss detection. And those people, they generate a report and then send it to city. So now the city just have the report, so they're gonna evaluate it. This process is not efficient at all. It's going to be very expensive. Just like some of the numbers, like if you want to get 2 or 3 weeks of that data, it can easily cost you more than $10,000 just for 2 weeks. And the other issue is that if you use camera, it doesn't necessarily provide insights about safety issues during low lighting condition, which is more than 70% of road accidents happening in those scenarios. So, and then you want to see these issues and safety measures or safety issues 24/7, and not just for based on 2 weeks of data or 3 weeks of data. So you can really build a solid conclusion about like the traffic issues in several months or years.
Okay, we're getting some great questions, so thank you, everyone. Are you doing anything related to the vehicle classification at the intersection level? What about pedestrian detection?
Yes, so we classify pedestrian, cyclists, vehicles. For vehicles, we have on our dashboard, we have 3 major classes. We have passenger vehicle, truck, and buses. And then we have some subclasses on our APIs, which we're not showing it on our dashboard. For example, for example, for trucks, we have trailer and tractors classified separate. So we have buses, articulated buses. We recently added tram to our system, our classification as well.
Okay, so we have some good mounting positioning questions. There's kind of 3 in a row. So I'll read them all, but if you need me to repeat stuff, let me know. Being mounted relatively low and on the corner of an intersection compared to camera detection, do large semi-box and box trucks create obstructions for different lane detections? Let's just start there.
Yeah, so actually, yes, that is the reason that in one of my slides, I talked about using this system for with 2 LiDARs, especially for large size intersection. In that case, we're fusing data from 2 different perspectives. We typically install LiDAR between 4 to 6 meters high, depending on size of intersection, higher to minimize occlusion problem. And if we really see a lot of heavy vehicles in those intersections, we might add a second LiDAR in the other corner of intersection, and we are fusing data between those. So I don't have a video here, but we do have cases that you can clearly see benefits of adding second LiDAR for intersection with, let's say, 7, 8 lane and more. So yeah.
Cool. For the current side of pole setup, can the sensor detect pedestrians on the same corner?
Yeah, so there is a small blind spot right now with the current LiDARs in the market, mainly because those LiDARs are set for autonomous vehicles. So the way that we are addressing it, sometimes we're tilting it a little bit down, so to just get the closing area. So if the pole is super close to the edge of the intersection, we might have probably a meter or 2 of blind spot. So, but again, like we're trying to solve this with new solid state LiDARs that Velodyne has to integrate with the current LiDAR system. So yeah, still like we are trying to keep the same pricing models, like keep it cost effective, but with solid state, we can easily achieve that.
Right. Yeah, it's exciting what we can do with solid state and rotational. They both have their benefits. Okay, for the field user or the integrator, what does the user interface look like in terms of setup for the detection zones and configurations? And a related question is, yeah, who in the city, who is that field user? Who is the integrator? And then what is their UI?
Yes, setup process is super easy. So for our case, what we do is when we ship the sensor to customers, which are municipalities, we do a lab test. We make sure that all the IT connection, everything is okay, and then we're setting a meeting to evaluate the intersection, looking at pictures and making sure that we're selecting the best loop corner of the intersection and pole. And then they're going to take it there. So right now we're supporting them. We're going to remotely see live stream of LiDAR data, and then we're providing them user manuals. So it's super easy for them. Our customers, they're doing typically like in an hour or 2 max. And then after that, we always have remote access to our system, so we can set those virtual loops, run the algorithm, making sure that everything is working. Eventually, everything will be handled by the city, but right now, city will have access to our platform, which is basically they can modify those virtual loops that we define. Right now, we define first, and then they have the option to modify those. And then with respect to the question about who is installing, who is using data. So again, like with respect to the installation, it depends on the city side. Some cities are doing by themselves, like they have the team. Some larger cities, they are working with integrators or contractors. So it really depends on the size of city.
Okay. Can your Purdue dashboards be plugged into ATSPM?
Well, yeah. So every chart that you saw, all the analytics, we have an API for that, so they can potentially use our API to extract this information without logging into our dashboard.
Okay, we have another. This is great. So many good technical questions. How do the sensors communicate to your servers? Does the city need to establish communication links?
So there are two components in our system. If the city wants to use this system for traffic actuation, no analytics, no SPM. So in that case, all they need is just connecting to the traffic controller. So we still need internet connection if you want to upgrade something, but it's not necessary if the system is operational. There is a second component, which is those analytics that I mentioned that we build on top of solution. In that case, yes, there should be a communication from our sensor to our cloud platform, but we're not sending raw LiDAR data. We're just sending metadata. That's why we typically don't need high bandwidth network infrastructure. So we can use LTE or we can use city fiber network.
Okay, let me see. I think we can do one more. What kind of feedback have you gotten from cities, and where are these cities? Where in the world where are we deploying?
Yeah, so I think in North America, we're right now in 15 different municipalities, Austin in Texas, Austin and Dallas in Texas. So in Florida, we have Boca, Gainesville, we have San Jose and Irvine in California, 3 cities in Canada. We have 2 cities in Europe, which is expanding quickly because of the privacy of LiDAR.
Right.
And also in one, we have a project in Australia. So it's growing fast. So I probably am not up to date with respect to the projects, but in general, I think one good feedback that we see is that like this is a system that different stakeholders are using this. So for example, with City of Austin project or San Jose. So in our meetings, there are people from Region Zero team. They're using our safety analytics part. There are people working on traffic operation. They're using our SPMs. So that is really making the solution really cost effective for cities. So yeah.
What kind of feedback are you getting? I know I've been on calls with the City of Austin, and they're very enthusiastic. What kind of feedback are we getting from the cities about using the system and how it's helping?
Well, I mean, what always we always try to do when we launch a project or pilot project, some of our projects already expanded to 15 plus intersections in a couple of cities. So first of all, when we launch a project, we run a couple of case study on accuracy of system, and we share this information along with all the manually counted object, let's say classification, etc., with our partners, so to just make sure that they are confident about accuracy of system. And we have a couple of cases studies that our partners shared with us. They generated about accuracy of system. Overall, I mean, I think in overall, like we can satisfy our customers. They are super excited about the performance of the system, accuracy and features. And definitely we are still working with them closely. We typically have bi-weekly meetings with them to go over the challenges that they might have, if they want to ask for, like if they're asking for a specific feature in our system, so we want to make sure that we add it to our product roadmap. But generally, they're really happy with the performance of system. And that's the reason that those are expanding. So
right, exactly, they're growing. Fantastic, Asad. Thank you so much. Really appreciate you being here. And like I said, I'm excited for our May 13th, so we can keep talking about all the potential that the system has for cities.
No problem.
All right, I think we're ready to close up. If we didn't get to your question, I think we finished most of them, but if we didn't, please feel free to reach out. There's some contact information here on the screen for Asad and for Velodyne. You can also go to the Velodyne website, velodynelidar.com, and go to our product page, or we made a handy little short link for you, vldr.events/IIS. That will take you directly to the Intelligent Infrastructure page, where you can get tons of information and also connect with an expert and set up a meeting to talk more. All right, so May 13th, please join us, 10 a.m. again on a Friday. We will be speaking with Asad further, talking about intelligent infrastructure. And as he said, we'll be expanding into the Vision Zero and safety aspects of the system and how IIS can impact urban planning. If you want to register, you can today. We have the link up. You go to vldr.events/urban planning. For all these short links, make sure everything is lowercase, and then it will take you to the right spot. That's it for today. We really appreciate you all joining. We appreciate the fantastic questions. It was a wonderful conversation with Asad. And like I said before, we will be following up soon with an email, which will contain a link to today's episode. So keep an eye on your inbox so you can get that and come back and dissect all the info that we got from Asad, because there was a lot of it, and we really appreciate the detail. Thank you all so much, and have a great weekend.